when you run application, the exe binary is loaded into memory. I'm modifying this page, not modifying the exe on the disk.
No, I understand. But
Yes,
I thought that,
yes. So I am modifying the code on the fly.
I understand. But I thought that the segment internal processor, I mean, the segment of memory pointed by executable by code register. It is special memory is protected. I mean, why processor is not revolving?
It's not, because this page was unlocked by .NET. Because when it compiles the IO, the JIT compiler needs to unlock the page to store some code, and it's not locked afterwards. If you would try to modify like pre-compiled method, for instance, the constructor of a thread, it would crash. I mean, it would require you to call first virtual alloc x to unlock the page. Here the page is already unlocked, so you can modify it.
I saw you use earlier some code editing instructions. Are those safe to use? I mean, is the compiler going to generate some code that won't crash, or it's up to you?
You mean those lines?
Yes. Well, no, not these, but using the .NET code edit.
Oh, those. No. I might be wrong here. If you emit the code using reflection emit, it should be verified when you try to run this code. So it should be verified because it needs to be JIT compiled to machine code. Yes. So in that case, I think it would be verified. Here, of course, it would not be. Cool. Yes.
How did you get from this code? How did you get the instance or the memory location of the new operator? Is it the first line?
It's this, I think. Yes. What we are doing here is, and by the way, this is running in release mode, not in debug, as you can even see here with flags. What I'm doing here is I have a very little helper method, which should be somewhere here. Is this it? Let me see. No, it's here. Create object. I have very simple helper method, which just creates a new object and has no optimization, so it won't be inlined. So I know this method will contain the machine code for allocating the object. And I know that this byte from the beginning is the address of the .NET allocation method. So if you would like to port this to other runtimes or port this to different architecture from x86 to x64, apart from changing the machine code you generate here, you probably would need to tune the addresses here as well. Okay, any other questions? Cool. So, assuming there are no other questions, it's QA time. No other questions. So, yes, yes.
NuGet. Do you have anything on NuGet that would?
I thought about releasing this as a NuGet package. I don't want to. I bet people would start finding edge cases or normal use cases where it. And by the way, this demo for you you might not want to run this in production anyway. Yes, this is showing why you don't want to run this in production. I had just one allocator method on .NET Framework. There are actually 10 of them. There is different method allocating arrays, different method for allocating generics, etc. You would need to hack all of them. You would need to change the addresses for x86, x64. You would need to test it on different operating systems probably. That's why I don't want to release this as a NuGet package. However, the demo 3, which is just a memory allocator, oh, it could be. I think it should work pretty reliably. As a side note also, the thing we were doing in first demo, allocating object on a stack, people from Roslyn, they were considering adding this stack alloc or some attributes, so you could mark the method that, hey, do not allocate the objects on the heap but on the stack for performance benefits, yes? And as mentioned also, memory of the and span of TR for similar cases. So the thing we are doing here, they might be not unreliable in this case when they are like implemented in this manner. However, if you pay enough attention, it should work correctly for all the use cases. Okay, references. If you are interested in the topic in this area and you would like to learn a little more, first thing like CLR via C#, this is of course obvious choice if you would like to figure out what is happening a little more under the hood when you run your C# code. Then if we go down the line, Windows via C++, pretty nice book explaining how to program, how to write applications for C++ for Windows from the user space perspective. Then Windows internals, pretty nice book, however very long, describing like all the internals of Windows, all the kernel stuff. And if you'd like to finally implement something in the kernel mode, developing drivers with the Microsoft Windows Driver Foundation. Yes? If instead of just reading about the code, you would like to see this in action and figure out how to use WinDebug I am using during this talk, there are actually two nice books by Mario Hewart, Advanced Windows Debugging and .NET Debugging. There are also, I think, courses on plural site with the same titles. If you would like to write your own memory manager in .NET application by the right way, not like hacking memory I'm doing here, you can actually do it very easily. This is something which is done by Internet Explorer or by SQL Server or by any other like runtimes hosting the .NET. You can actually host the .NET on your own and replace some of the implementation like tracking memory or tracking logs, etc. How to do it? Customizing .NET CLR. This book explains everything. If you are interested in .NET IL, like down to the every single bit of metadata, expert.NET 2.0 IL assembler, even though it's for 2.0, it's still very relevant because like the content hasn't changed a lot. If you would like to see some .NET sources, first, Rotor, so shared source CLI 2.0. This is this research implementation of .NET, which was there 10 years ago. Yes, .NET was a little open sourced 10 years ago also. And a book of the runtime describing core CLR, so the thing you can see on GitHub pretty easily. Some like things you can read on the bus. If you are interested in what I'm doing here and even more, on my blog there is an allocating object on a stack node and also the whole series of custom memory allocation where I play with this. If you would like to see this again, you can just read the post. If you would like to learn some tooling, Windows tooling like WinDebug, but also some others, there is Defrag Tools on channel 9. If you like debug something and see how does it work to debug like memory leaks, locking issues, etc. Great demos by Tess Fernandez. And finally, if you are just interested in the internals of anything, any architecture, any Windows stuff, and some funny like true stories from Microsoft team, Raymond Chen and the old new thing blog. If there are no more questions, then my name is Adam Furmanek and I'd like to thank you for attending this talk.
I have a quick question. Have you done similar investigations for the JVM at all? Or?
JVM. JVM, when it comes to memory structure, is very similar. I mean, also sync block, Google pre-calculated hash, RTTI, and fields. When it comes to allocation by hand, there is package called SUNSAFE, which you can use a lot to do the same thing. And by the way, Java guys are using this a lot, much more than we use in .NET. When it comes to other internal quirks of implementations, there is a blog called Mechanical Sympathy, I think, which I could recommend about Java internals. And since Java is open source for much longer than .NET, you can read like JVM specifications, so all those things are described.
Okay, so .NET is more mysterious, so you can...
It was more mysterious. Now with book of the runtime, it's like you can read a lot about the internals, and this Rotor source code you could read also like 10 years ago, but now with just GitHub project, you can do whatever you like. Thank you.
Thank you.